Hi guys, welcome back to my channel. For today's video, we are going to have the summary on chapter 5 until 5.4. Chapter 5, which is entitled the Ethernet. So let's start. Chapter 5, the Ethernet. In 5.1, there is Ethernet protocol. Explain the operation of Ethernet. In 5.2, there is a LAN switches. Explain how a switch operates. Chapter 5.3, or address resolution protocol. So let's start with the 5.1, Ethernet protocol. Ethernet frame, which is Ethernet encapsulation. Ethernet is the most widely used LAN technology today, defined in the IEEE 802.2 and 802.3 standards. Ethernet operates in the data link layer and the physical layer. Ethernet relies on the two separate sublayers of the data link layer to operate, the logical link control and the MAC sublayers. Ethernet encapsulation. The Ethernet LLC sublayer handles the communication between the upper layers and the lower layers. It is implemented in software and its implementation is independent of the hardware. The MAC sublayer constitutes the lower sublayers of the data link layer. It is implemented by hardware, typically in the computer NIC. MAC sublayer has two primary responsibilities: data encapsulation, media access control. The data encapsulation provides three primary functions, which is the frame delimiting, addressing, error detection. Media access control is responsible for the placement of frames on the media and the removal of frames from the media. The sublayer communicates directly with the physical layer. Ethernet evolution. Since 1973, Ethernet standards have evolved, specifying faster and more flexible versions of the technology. Early versions of the Ethernet were relatively slow at 10 Mbps. The latest versions of the Ethernet operates at 10 gigabits per second and faster. The minimum Ethernet frame size from destination MAC address to FCS is 64 bytes and the maximum is 100,518 bytes. Using Wireshark to examine Ethernet frames, MAC address and hexadecimal. Hexadecimal is used to represent Ethernet MAC address, CES and IP version 6 addresses. MAC addresses were created to identify the actual source and destination. The MAC address rules are established by IEEE. The IEEE assigns the vendor a 3-byte by 24-bit code called the organizationally unique identifier. All MAC addresses assigned to an NIC or other Ethernet device must use that vendor's assigned OUI as the first 3 bytes. Frame processing. The MAC address is often referred to as burned in address BIA, meaning the address is encoded into the ROM chip permanently. When the computer starts up, the first thing the NIC does is copy the MAC address from ROM into RAM. MAC address representation, unicast MAC address, broadcast MAC address. A broadcast packet contains a destination of IPv4 address that has all ones in the host portion, indicating that all hosts on the local network will receive the process and the packet. Multicast addresses allow source device to send a packet to a group of devices. Devices in a multicast group are assigned a multicast group IP addresses in a range of 224.0.0.0. Viewing network device MAC addresses. 5.2, which is LAN switches. In switch fundamentals, there is a layer 2 Ethernet switch makes its forwarding decisions based only on the layer 2. A switch is powered on. Note that the MAC address table is sometimes referred to as a content addressable memory. Learning MAC addresses. Switches examine all incoming frames for new resources, MAC address information to learn. If the source MAC address is unknown, it is added to the table along with the port number. If the source MAC address does exist, the switch updates the refresh timer for entry. By default, for most Ethernet switch, keep an entry in the table for 5 minutes. Learning MAC address. If the destination MAC address is a broadcast or a multicast, the frame is also flooded out all ports except the incoming ports. Filtering frames. As a switch receives frames from different devices, it is able to populate its MAC address table by examining the source MAC address of every frame. The video demonstration, which is MAC address tables on connected switches. The computer is going to send a packet to the internet because the destination IP address is in another network. Viewing the switch MAC address table. Frame forwarding methods on Cisco switches. Switches use one of the following forwarding methods for switching data between network ports, which is stored and forward and cut through. Memory buffering on switches. An Ethernet switch may use a memory buffering technique to store frames before forwarding them. Buffering may also be used when the destination port is busy due to the congestion and the switch stores the frame it can be transmitted. There are two types of memory buffering techniques: duplex and speed settings. Full duplex. Both ends of the connection can send and receive simultaneously. Half duplex. Only end of the connection can send at any time. Auto MDX. Connection between specific devices such as switch to switch, switch to router, switch to host, and router to host devices. One require the use of specific cable types. 5.3. The Addressing Resolution Protocol. Destination on same network. There are two primary addresses assigned to a device on the Ethernet LAN. Physical address, the Ethernet MAC address. As an example, PCA sends an IP packet to the file server on the same network. The Layer 2 Ethernet frame contains destination MAC address, source MAC address. The Layer 3 IP MAC packet contains source IP address, destination IP address. Destination on remote network. When the destination IP address is on a remote network, the destination MAC address will be the address of the host default gateway. In the figure, PCA is sending an IP packet to a web server on a remote network. The destination IP address is that of the file server. The destination MAC address is that of Ethernet interface of R1. Packet tracer. Identify MAC and IP addresses. Introduction to ARP. When a device sends an Ethernet frame, it contains these two addresses: destination MAC address, source MAC addresses. To determine the destination MAC address, the device uses ARP. ARP provides two basic functions: resolving IPv4 addresses to MAC addresses, maintaining a table mappings. IRP functions. Ethernet devices refers to an ARP table, or the ARP cache in its memory to find the MAC address that is mapped to the IPv4 addresses. Video demonstration. Only the device with an IPv4 address associated with the target IPv4 addresses in the ARP request will respond with an ARP reply. When a host creates a packet for a destination, it compares the destination IPv4 address and its own IPv4 address to determine if the two IPv4 addresses are located on the same layer 3 network. Removing entries from an ARP table. Every device has an ARP catch timer that removes ARP entries that have not been used for a specific period of time. The times differ depending on the device operating system. As shown in the figure, some Windows operating systems store ARP catches entries for 2 minutes. You can also manually remove all or some of the entries in the ARP table. On a Cisco router, the show IP IRP command is used to display the ARP table. On a Windows host, on a Windows 7 PC, the ARP A command is used to display the ARP table. Packet tracer examine the ARP table. ARP requests can flood the local segment when a large number of devices were to be powered up and all start accessing network services at the same time. Attackers can respond to requests and pretend to be providers of services. One type of ARP spoofing attack used by attackers is to reply to an ARP request to the full gateway. Chapter 5 Summary. Ethernet explain the operation of Ethernet, explain how a switch operates, and explain how the address resolution protocol enables communication on a network. So, we're done in Chapter 5 Summaries until Chapter 5.1 to 5.4. Thank you guys for watching. See you on my next video. And please don't forget to subscribe and click the notification bell so that you will be updated on my other videos that will be uploaded. Bye guys!